Alright, so in this video we're going to be learning about how to find the surface area and volume of two different kinds of figures. So first, let's just talk about what those words mean. So up at the top of your paper, I want you to write down our new vocabulary. Whenever I talk about surface area, that's when I'm talking about covering something completely, so covering the entire outside. For example, words like cover, over, these are words that are clues that you're going to be finding surface area. That's our first vocabulary word. Our next vocabulary word is volume, and this is one that more people have heard of. Volume is when we fill up a figure. So some of our clue words are fill, inside, anything that's going to completely cover up or completely fill up that picture. So on your paper right now, you should have those two vocabulary words written down, and then underneath that, I'm going to have you cut your paper into 4 boxes. So whatever room you have left, we're going to go ahead and make 4 big boxes on your paper. Now in the top left box, this is where we're going to talk about our first figure. It's called a rectangular prism. Now, a rectangular prism is really just a fancy word for what looks like a 3-dimensional box. So things like, an example would be a tissue box, cereal. These are examples of rectangular prisms in real life. On your rectangular prism, there are 3 different measurements that matter. When we talk about the distance going up and down, that's what we call the height. And everything I'm writing, you've got to write. When we go left to right, that's going to be my length. I'm going to use a cursive L so it doesn't look like a 1. And then, when I go, back, on my color, there we go, that's going to be a W, which stands for width. So let's talk about our formulas. These are things that you do not have to memorize. You are going to get a formula sheet when you take your SOL, when you take your big tests. These formulas, though, you do need to know how to use them. So I'm going to go ahead and give you your 2 formulas here. When we talk about the volume of a rectangular prism, so the volume of my rectangular prism, I need to multiply the length times the width times the height. When I talk about the surface area, and I'm going to shorten these, so SA stands for surface area, this one's a little bit longer. I have to take 2 times LW, so length times the width, add that to 2 length times height, and then add 2WH for width times height. So pretty much what I'm doing is finding the area of each one of those rectangles, so length times the width would give me that. Now our other shape Let's go ahead and do our examples here below that. So in the bottom left, we're going to draw our example. I'm going to give us our rectangular prism, and remember, you need to draw your pictures or else your notes won't make sense. And on my rectangular prism here, I'm going to label the length as 7, the width as 3, and the height as 4. So let's go ahead and find our volume first. Whenever you're showing me work, I really want you to make sure, and I'm actually going to do volume up here. Whenever you're showing me work for our volume and surface area, I want you to always start by giving me the formula. So length, width, height was my formula. Now I'm going to go ahead and plug in those numbers. Well, my length, remember that was going across on the bottom there. That's going to be 7, so when I plug that in, I want parentheses. My width was 3, and my height was 4. When I multiply all of those together, I've got to go left to right because it's all multiplication, so you've got to start at the beginning. 7 times 3 times 4 is going to give me 84. Now, because we're talking about measurements, it is important that we know that it's inches. Sorry, I forgot to add that in my drawing earlier. So my label here is going to be 84 inches, and then this is something that you really have to make sure that you remember. It is 84 inches cubed. So I need a little 3 right there. The reason that it's 3 is because this is a 3-dimensional picture. Just like for area, that's a 2-dimensional picture. I had 2 different sets of measurements that I multiplied. This one I have 3. I have 7 times 3 times 4. So that's 3 inches, so inches cubed. All right, let's go ahead and talk about surface area now. In surface area, our formula is a little bit more involved. So I want to go ahead and rewrite that first. So I've got 2 length width plus 2 length height plus 2 width height. So let's go ahead and start plugging these numbers in. Well, I need to bring down 2, and then in parentheses my length was 7, and my width was 3. Then I'm going to add 2 times the length again, which was 7, and this time I'm going to use the height, which was 4. And one more time, 2 times the width was 3, and the height was 4. And you can see how many numbers I have to plug in here. So that's why it's so important to make sure that your work is completely clear and very, very neat. So let's go ahead and start typing these in my calculator. We need to solve each one of these separately because you can see that there's a plus sign in the middle. So it's almost like I've got 3 sets of multiplication problems that I'm going to put together at the end. So first, let's do that first one. 2 times 7 times 3 gives me a grand total of 42. My next section, 2 times 7 times 4, is going to give me 56. And then that last one, 2 times 3 times 4, gives me 24. And now I've just got to add those 3 numbers together. So I have a lot more steps when it comes to surface area. So 42 plus 56 plus 24, when I type that in, I get 122, and then I need that label there, inches, and because this is surface area, I need to make sure that I have squared units. So remember, surface area always has units squared and volume has units cubed. So the surface area of this picture is 122 inches squared, but the volume was 84 inches cubed. Alright, our next shape that we're going to talk about is our cylinder. So put that at the top of the right-hand side of your paper. Now a cylinder looks like a circle with 2 straight parts and then a curved bottom. And that base is also a circle as well. So on a cylinder, there's kind of 3 different measurements that you could see. Once again, however tall that figure is, that's going to be the height. And that one's usually a pretty easy one. And the other 2 measurements have to do with a circle. If they tell us just from the center to the edge, that's what we call the radius. I'm going to go ahead and write that down. H was again the height. R is the radius. And then our last measurement is the diameter, which is the distance all the way across one of those circles. Now, in our formulas, we are really going to be dealing with radius, not diameter. But you do need to know that if they give you the diameter, you can figure out the radius by dividing it in 2. So make yourself a little note. If you divide by 2, you can go from the diameter to the radius very easily. Some examples of cylinders in the real world. Really anything in your canned goods aisles. So if you have soda cans, if you have soup, those are all examples of cylinders that you can see. Now our 2 different formulas, we've got volume, which is pi, and we talked about pi during Pi Day, pi r squared h. Surface area, again, has a little bit more going on. That's 2 pi r squared plus 2 pi r h. And once again, surface area is going to give us a little bit more work, and we're going to see that in the example. Alright, let's go ahead and draw our example cylinder here. And the nice thing is that this sheet of paper is going to have everything that you need for this section of our unit. So in this cylinder, we're going to go ahead and draw a circle with those straight sides going down. And then you need to label 8 right here, and then a line going all the way through that circle with a 6 labeling that. Now this one is a tricky one. They are trying to trick you here. You'll notice that 6 is not the radius, 6 is the diameter. And so in order to find the diameter, or the radius, you do 6 divided by 2 to find 3. So that 3 is our R. So if you wanted to make yourself a little note that 3 is the radius here. Alright, so let's talk about volume. Volume starts out with our formula. Remember, we always want to keep it very neat. So pi r squared h. And we're going to go ahead and use 3.14 for pi for our purposes. We know that there's a lot more digits. I'm going to plug that into my calculator. R, we just figured out, was 3. Keep that squared on it. And then h is going to be that 8. So now this goes back to PEMDAS. I can't start with that 3.14. I have to start by figuring out that 3 squared, which I know is 9, and bring everything else down. Now I can type that in. 3.14 times 9 times 8 gives me 226.08. And we're going to go ahead and assume that it's inches again, just like the last example. And remember, volume gets inches cubed. Alright, now for surface area, remember we have more going on here, so make sure you are writing down everything that I write down. I start out with 2 pi r squared plus 2 pi r h. And now let's start plugging in those numbers. Well, I'm going to keep 2. Instead of pi, I'm going to put 3.14. Instead of R, I'm going to put that 3, and don't forget the squared. There's my plus sign. Then I've got 2 instead of pi, 3.14. R is going to be 3, and H is 8. Wow, that's a big problem, but really it's 2 baby problems. I've got this part here and this part here that I'm going to add together. So remember, you've got to do that 3 squared first to get 9. So now 2 times 3.14 times 9 gives me 56.52. And on the other side, I can just go ahead and solve this. 2 times 3.14 times 3 times 8 gives me 150.72. Bring that one down. Ran out of room here, so I'm going to add a little bit to my page. I know it got pretty small. So now I do 150.72, add the 56.52 that I had before, and I have my total of 207.24 inches. And remember, this is surface area, so it needs a squared unit on your answer. And you will lose points for that, so watch out. Alright, so this little sheet of paper, it has a ton of information on it, but you definitely need to know how to use these formulas. Remember, you don't have to memorize them. That's a lot to memorize. I'm not telling you to do that. I'm just asking that you know how to use those formulas. Alright, and we're going to get lots of time to practice in class.